Most home safety systems are designed to wake up only after a fire has already started. Devices like smoke alarms and arc fault circuit interrupters act as emergency tripwires. They trigger only once a hazard is active. By the time these sensors detect a problem, the building's physical structure is usually already burning. The real danger builds invisibly in places like this metal junction box, where tangled, congested wiring generates heat long before a flame appears. Electrical resistance heating creates a slow, quiet path to failure, lacking the obvious signs of a late-stage blaze. True safety requires the ability to spot a pre-ignition state before that first spark ever occurs. Inventor Shane Persinger developed the firewire concept to fill this gap in safety engineering. It is not a smoke alarm. It functions as an advisory system designed to detect the risk level of a circuit before it ignites. The hardware identifies thermal anomalies and correlates that heat with the electrical behavior flowing through the wire. This shifts the focus of the technology from managing an emergency to preventing it entirely at the source. The system architecture follows a three-step logic: sensing, thinking, and alerting. The first layer relies on an anchor sensor, a digital temperature probe placed directly against the electrical wiring. It ignores general room temperature changes, focusing exclusively on localized heat spikes traveling along the wire. This sensing layer provides an early warning based on thermal reality without needing smoke to be present. The data flows into the processing core, an Arduino Nano microcontroller. This unit continuously pulls the sensor, comparing live data against the normal operating temperatures of the house. This graph shows the core logic: risk equals pattern over time. Notice how the thermal load suddenly diverges from the electrical current, signaling a problem. This pattern recognition prevents false positives by distinguishing between the normal heat of a running appliance and the dangerous heat of electrical resistance. The system does not simply announce a fire. It proves mathematically that a specific wire is behaving dangerously. Moving this concept from a blueprint to a physical object requires the Synestex approach to rapid prototyping. The goal for the initial bench build is to isolate the variables and prove the thermal heartbeat before adding complexity. Wiring the digital sensor to the microcontroller is the first step in creating that proof. The red wire connects to the 5-volt pin for power, while the black wire provides the ground. The blue data line routes to digital pin 2. A 4.7 kiloohm resistor is added here to stabilize the digital signal. This breadboard setup confirms the system's core capability. It can detect abnormal heat and react autonomously. In the world of patent strategy, the FireWire project was parked due to prior art. The value of this case study lies in the engineering process it makes visible. The methodology involves identifying a safety gap, designing around regulatory hurdles, and building an undeniable physical prototype. This combination of high-level logic and hands-on execution defines the company's operating model. We invite investors and partners looking for this level of intelligent prototyping to reach out. If you found this build interesting, please give a like and subscribe. FireWire was designed by founder Shane Persinger for Synestex Systems LLC.